All right, so let's go ahead and take a look at question number 1. And the directions are find the x and y intercepts, then graph the equation. All right, so they give us the equation 5x minus 30y equals 30. And the easiest thing to do when finding x and y intercepts, and when they've been, or when we've been given an equation rather, is to quickly draw just a small xy table. And what you want to do is, in one of the x columns, you want to fill in a 0, and then in one of the y columns, you want to fill in a 0. And the reason that we do this is because when we're finding x and y intercepts, we're actually going to be plugging in 0 for x and y twice. When we find the y-intercept, we plug 0 in for x, and when we want to find the x-intercept, we plug 0 in for y. So we plug 0 in to the given equation for the opposite variable of what we're trying to find. So let's take a look at what that means. So for the first part of question 1, we're going to find the y-intercept. So if we want to find the y-intercept, that means we plug 0 in for x. And what does that look like? Well, 5, and now anywhere I see an x in our given equation, we're going to plug in a 0. So 0 minus 30y equals 30. And then go ahead and evaluate this equation just like you would any other time. So 5 times 0, well, that's 0, so that just goes away. And so we're left with negative 30y equals 30. And now solving for y, algebraically, we'll go ahead and divide by negative 30 on both sides. And that's going to leave us y equals negative 1. All right. So now we've been able to find the y-intercept. And remember, in a t-table like this, in a table, these become just an ordered pair, right? This is our x, this is our y, so we have 0, 1. All right, let's go ahead now and find the x-intercept. And to do that, like I said, we plug in the opposite variable with 0. So if we want to find the x-intercept, we're going to plug 0 in for y into our given equation. So now we have 5x minus 30, plugging in that 0, equals 30. And now let's solve for x just like we would any other time. Well, we know negative 30 times 0 is 0, so that whole thing goes away. So when that happens, we're just left with 5x equals 30. And solving for x, we'll go ahead and divide by 5 on both sides, and that's going to leave us with x equals 6. All right, and now again, these become just an ordered pair. And now we know how to plot these, right? Let's go ahead and plot this first point here. So 0, negative 1. So 0 on the x-axis, so we're not going anywhere, but we're going down to negative 1 on the y. So there's our first point. And now we're going to go to 6, 0. So 6 on the x, and we're not moving up or down on the y. So right there. All right, and then as soon as we have 2 points, we're able to connect the dots and have a line, because all we need for a line is 2 dots. So I'm going to try to connect this with as straight a line, and that's not very good, is it, as possible. So let's see. There we go, something like that. All right, so again, when you're finding the x and y intercepts of a given equation, if you want to find the x-intercept, plug 0 in for y. If you want to find the y-intercept, plug 0 in for x. And go ahead and just create a little t-table here, and then that way you can easily fill out the values that you get when you evaluate each equation. And from this table, you're able to derive 2 ordered pairs, plot those ordered pairs on your graph, and connect your 2 dots, preferably using a ruler, right? So you get a little nicer line than I have here, but you get the general idea. And so not only did we find the x and y intercepts, but we also graphed this equation.